We're now on the predict pane, and let's go to algorithms. And here we have automatically added the hierarchical clustering piece. So let's click and drag it here on the canvas. And I'm going to click on settings and go to configure settings to see how it's really set up. So the first thing we need to do is the number of clusters. Let's leave it at 5. So that's good to cluster those cities into 5. And now it's a more intricate customer user interface piece. So it lets us select a row label, which is essentially the city. So every row has a city name, which is essentially a label there, which tells us what city it is. The second thing is what to use for clustering. So I'm going to go ahead and select all the columns besides city. So all the information will be actually in there. And we already know that we don't need scaling, so let's do false in scaling. And there are many distance methods. We'll be talking more about distance, like correlation distance, Euclidean distance under recommender systems. There's Manhattan systems, distance which pertains to Manhattan system where you have streets only going left, right, up, down, and many others. So won't go into detail describing all of these, and many clustering methods for using as well. But we just let you experiment with those to get slightly different results. Now it's done. The configuration is done, and maybe the next thing would be to look at how this R custom component really was built up. So let's click on hierarchical clustering. Let's do edit. And here we see that first of all, it's just a name and that it's an algorithm that's being run. Under R, we can see the R code there starting and finally ending. We have the my main, which is the main program, my data, which is the European urban data, out is the output. But now a different thing is that it uses a visualization. So we'll be seeing a visualization in a second as well. Now, under next, this more difficult customer user interface piece. So first of all, when it outputs, it doesn't output new data, like consider none, but it outputs all columns from the previous component and just adds the cluster number. So that's what's being done here. In the previous case, we just had new data coming out. And then the way to enter all these things, the first is the number of clusters, which is a text block with a default value of 5, so that's fine. The second one is a row label, which lets us select a city as a column to be used as row labels. But you can see that it's a column selector. So here you can really let the user choose from amongst the columns of the input data. And now the next one is column selector, and it's even a multiple column selector. So there you can let it choose all the input dimensions or all the input columns of the data. So these are built in here. And then there are so a text box, a column selector, a multiple column selector, and now even a drop-down box where you can choose your true or false. And later you can choose your Euclidean, maximum, Manhattan, and so forth distance. And then you can use the clustering method, again, drop-down box. So you see that out of all, we've exhausted almost all the user interface options. We haven't looked at the combo box, which is a slight variation. So really quite a few things to select here in designing this user interface. And I'm just going to cancel in case, because I don't want to change anything in this component by accident. So here we are. Let's go ahead and run this component now. So it might take a while to run. So let me pause in the middle. And it's done with the execution quite quickly. And now here we can see that in the data, there is a cluster number that's been added to it. But the main thing to look at is the visualization, which is a custom chart. I'm going to go ahead and click on it. And this is actually a kind of a result of hierarchical clustering. So what you see here is it has clustered both the columns, the next with the tendogram, and the rows with the tendogram. And all those colors even suggest whether a value is like a higher end value or a lower end value in our data. So let's try to go through some of that. First of all, we can see that in the clustering of columns, the two things that are most similar to each other while doing this clustering are green spaces and sports facilities. So it essentially says that in cities where people are happy with green spaces, they're also very often happy with sports facilities. So these tend to go together. So kind of again understanding all the city data that we're drilling into. Another thing is what is actually the most far apart cluster that has been created between two columns. And the next on the left side, which is affordable housing and good jobs. So think about it. Of course, if there are many good jobs in the city, it might not be as well as it might not be doing as well in terms of affordable housing. Okay, so now let's take a further look. If we want to see which city is clustered together into the same cluster with another, we have to go to Visualize. And there we have to take Table and put on row axis the city names. And then we have those clusters, and we have to do the Create Measure again here for the cluster information, and then put this cluster on primary values. And then we have to sort it here. So here you are. The first cluster is formed by Aalborg, Belfast, Cardiff, Glasgow, and so forth. So these cities are all clustered into one. This doesn't tell us very much, unless of course you wanna, as I did, I wanna check out my home city, Tallinn, which is together in cluster 5 with Rome, Rostock, Torino, Verona, and so forth. But there is another way we can approach this data. Namely, we can look at how the clusters of cities are formed. For that, we will take a decision tree, which is RC, the next, and configure it. So what we need for it to do, and we'll talk more about decision trees in the next learning module. The next fill with that tree, we're going to be doing classification. So it's on either it's a city in cluster 1, 2, 3, 4, or 5, and the target variable that we're going to be predicting with decision trees. Remember, classification let us predict whether someone is going to buy or not, churn or not, be delinquent or not. Then right now we're just going to predict what the cluster will be. And then we're going to put all the other variables, of course not the city name, but all the other variables in there. And we're going to run this decision tree. And what decision trees do is they kind of give us such a, and let me go on results, under predict, under results to model representation. And I'm going to also hide parts of that decision tree to make it kind of more digestible and more to bring out some important points here. So essentially, what we see is that like the biggest deciding factor somehow of what cluster the city is going to fall into is the sports facilities here, which is kind of non-intuitive, but we'll get to some better read results later on. So if sports facilities are over 67, then comes the second split in the tree, and let me show you here. Now comes the split that good jobs. So good jobs are either under 32 or over 32, and if the city has many sports facilities, has many good jobs, then comes the next split. It's either under 43 or over 43, and what we see is that if we go through all these three splits, the first being sports facilities, the second good jobs, and then third affordable housing, then in cluster 1 we have cities which do have affordable housing and good jobs and big sports facilities. and these are basically purely cluster number 1, whereas cluster number 2 contains cities which have sports facilities and good jobs, but not so much affordable housing. So this way we can see how kind of the prediction process of this clustering went when we modeled the clustering results by decision tree. So this is how to kind of interpret it in a combined way. And let us now go and see which cities are in which cluster. So first of all, we're interested primarily in the first and second cluster. So under visualize, we still have that clustering result. And as you can see, in the first cluster, which was sports facilities, yes to good jobs, yes to affordable housing, it's smaller cities like Aalborg, Belfast, Cardiff, Glasgow. Whereas in cluster 2, where you still have like good sports facilities and good jobs, but you don't have affordable housing, these big cities like Amsterdam, Helsinki, Hamburg, and so forth. One further note to make is that if we go to predict and open up this hierarchical clustering, their results, and hierarchical clustering's custom chart, then we can see that the distance between the first cluster and the second cluster is quite small, because the next into one cluster up here, whereas the distance, let's say, between the first cluster and the fifth cluster is quite a bit bigger. So here you see column clustering, where it shows which columns go together, the city clustering, which rows go together, and finally here on that so-called heat map, since everything was between 100 and 0, we have all those raw values as well. So such a intricate clustering result.